So the last concept in this section is about a point of diminishing returns. This paragraph actually does a wonderful job explaining about this, so let's read this together. It says, in economics, the notion of concavity is related to the concept of diminishing returns. This is a very, very important business topic. It says, consider this function, y equals f of x, where x measures the input in dollars and y measures the output in dollars. So if we look at this figure, what's happening? So the first section that we want to consider is this section from A to C. Notice this section is concave up, which means its derivative is positive. The function is increasing. As each dollar you input, the output increases. But it's also getting more steeper or more positive. So what does that interpret to? That says it's concave upwards on this interval, and it's concave downwards on the next interval. Concave downwards on the interval from C to B. So, what does concave upwards mean in this sense? Well, there's a great way of explaining this in the next section. It says, on the interval A to C, the blue area where it's concave up, each additional dollar of input returns more than the previous input of the dollar. So investing a dollar, the next dollar you input, you're going to see even more of a return than you did with this one. Then it says, by contrast, on the interval C to B, the red interval here, it says each additional dollar of input returns less of a return than the previous input dollar. So it's not that your output's not increasing, it's just not increasing by as much. So what you want to do as an investor is be investing in this time, the blue area where it's concave up, and the best that you can get is this point of diminishing returns where each dollar you start putting in has less of an investment than the previous one. Well, what this is in calculus is this is a point of inflection. Finding the point of diminishing returns in economics is the exact same thing as finding the point of inflection. So any problem that asks you to find for a point of diminishing returns, all you're doing is looking for an inflection point. Particularly, you're looking for the inflection point when it changes from concave up to concave down. So let's read this problem together. It says, find the point of diminishing returns for the following revenue function, where R is the revenue in thousands of dollars. We do want to note that it's in thousands of dollars. We'll use that in our answer. And X is the advertising cost in thousands of dollars. Interpret the answer and write a recommendation for the company. Well, because it's a point of diminishing returns, I know that I need to find the second derivative. So that's the first thing that I did is I found the first derivative of the function. 1 over 2,000 is a constant. 450x squared, the derivative is 900x, and the derivative of x cubed is 3x squared. Again, it's the point of diminishing returns, the inflection point, so I need the second derivative, not the first derivative. So again, the derivative of 1 over 20,000 is 1 over 20,000. The derivative of 900x is 900. And the derivative of negative 3x squared is negative 6x. I need to set this equal to 0 or undefined. Well, I can set it equal to 0, but it is never undefined because it is a polynomial function. So solving this equation where it's equal to 0, I'm going to multiply both sides by 20,000 to get rid of the 1 over 20,000. I'm left with 900 minus 6x equals 0. I'm going to add 6x to both sides. I have 900 equals 6x. Divide both sides by 6, and I end up with x equals 150. Again, at this point, this is a possible inflection point because it's where the second derivative is equal to 0. I create my number line. Here I know I have to start at 0 because it doesn't make sense to start before 0 in this applied problem. And it can go on to however much this function works for, which is not stated in the problem. I break it up at our possible inflection point at 150. I look at my first interval, 0 to 150. I need to pick a point to plug in. I pick the point 10. And then I need to plug in any point bigger than 150. I pick the point 200. Again, I'm plugging this into the second derivative to determine the concavity. When I plugged in the number 10 using my calculator, I got a positive number. When I plugged the number 200 into the second derivative, I got a negative number. So that means my revenue is, the second derivative of the revenue is going from positive to negative, which means it is going from concave up to concave down, which means it is an inflection point. That means in this application problem, this is our point of diminishing returns. It's a point though, so I do need to plug this x value into the original function. I plug 150 into the original function, used my calculator, and I got the number 337.5. So I'm looking at the ordered pair as the answer. 150 was the x value, 337.5 is the y value of the inflection point, or in this application, the point of the diminishing returns. So what the heck does that mean? Let's look at x value. An x value is the advertising costs in thousands of dollars. So our 150 means they should spend $150,000 in advertising costs. 337.5 is the R value. That's the revenue in thousands of dollars. So if I spend $150,000 in advertising costs, I should expect a revenue of $337,500. That's what I have written right here. The company should spend $150,000 on advertising and should expect approximately $337,500 in revenue. Again, putting in the next dollar, if they put in $150,001, they're going to see less of a change in revenue than they did from the dollar before. So this point of diminishing returns is very important to companies.